Creating tables, graphing, and linear patterns. So in this lesson, what we're going to do is complete a table and make equations from a table in different situations. And we'll also have creating a table and graphing that table. Here's a problem where what we have is sometimes x and other times y, and we need to find the missing value. So for the first one, we can see that x is 1, and our equation is y equal negative 5x plus 4. So we don't know y, it's y equal negative 5 times 1 plus 4. Well, negative 5 times 1 is negative 5, plus 4 is negative 1. For the second value in the table, we can see that y, for the second order pair in the table, we can see that y is negative 6. This is y right here. So we'll take that equation, y equal negative 5x plus 4, and this time we put it in the y spot. Negative 6 equals negative 5x plus 4. So we have to solve. Get x by itself. The last thing we do is divide, get rid of the coefficient. So first of all, we'll subtract 4. That's negative 10 equals negative 5x. And we'll divide by negative 5. And we can see that x is 2. For the next one, we've got an x right here, 4. So our equation, y equal negative 5x plus 4, becomes y equal negative 5 times 4 plus 4. Well, that's negative 20 plus 4, and negative 20 plus 4 is negative 16. And for the last one, we have a y of negative 41. So our equation, y equal negative 5x plus 4, becomes negative 41 equals negative 5x plus 4. So we'll take a 4 off each side. That's negative 45 equals negative 5x. And divide by negative 5, and we can see that x is 9. One of the things you're going to be asked to do is to create an equation from a table. And that is a little tricky. Later on, we'll learn some more algebraic methods to do that. But what I'm going to do is build a table, and I want you to make some observations. Let's take in a simple equation like y equal 3x plus 5 and build a table. So if we plug in negative 1, 3 times negative 1 is negative 3, plus 5 is 2. If we plug in 0, 3 times 0 is 0, plus 5 is 5. Plugging in 1, 3 times 1 is 3, plus 5 is 8. And plugging in 2, 3 times 2 is 6, plus 5 is 11. Now make an observation. As you go down in the table, do you notice how every time it's plus 3, plus 3, plus 3? In fact, that 3 has a name. It's called first differences. But the thing that you should observe is that 3 is sitting right here. Since I'm multiplying by 3 when I plug it in, every time I increase x by 1, we get one more 3 in the table. So the way it works is as long as there's a pattern on both sides, and as long as on the x side you're increasing by 1, this difference between the numbers, 5 and 2 is 3, 8 and 5 is 3, 11 and 8 is 3, this first difference is always going to be what you're multiplying by. It's always going to be that number in front of the x. Another thing to observe, Do you see how when you plugged in 0, you got 5? That will always be the case, because when I plug in 0 for x, I'm always going to get the number that sits right there, because in this case, 3 times 0 is 0, and y ends up being 5. So the process again is to observe what y is increasing by. Make sure you're increasing by 1 on the x side. If the y increases by 5, the number in front of the x is 5. If the y increases by 2, the number in front of the x is a 2. If the y goes down by 2, then the number in front of the x is negative 2. And if you find the 0 value in the table, that will be that number that's being added and subtracted. Let's take a look at an example and see if we can build the equation. In this table, I see that the change as I move forward into the positives for x, that I'm going down by 3, down 3, down 3, down 3. That means the number in front of the x is negative 3. Then all I have to do is look at that 0 value. When I plug in 0 for x, I have to get y as 2. And the way that make that happen is a plus 2. If I plug in 0 for x, negative 3 times 0 will be 0, and y will be 2. And that's that point right there. Now you can check this and double check that you're right. If I plug in any point, let's grab a different point. If I grab this point and plug in x is 2, y equals negative 3 times 2 plus 2, I should get this value, negative 4. Well, negative 6 plus 2, yes, y is negative 4. When I plug in 2, I got out negative 4. I can see that that equation is correct. Here's another example of exactly the same thing. Notice how x is increasing by 1. That's what we need to make this happen. But a linear function, it could increase by 2 or 4, but that means that number in front of the x is going to be a fraction. For our first examples, we don't have to worry about that. Let's just get this down. Look for a change here from negative 1 to 0 right here. I'm increasing by 1, which is what I need to happen. And on the other side, from negative 6 to negative 5, careful, you're not decreasing by 1, you're increasing by 1. I'm going towards the positives. So negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, and negative 2. Now, I look at the y side, and I notice that I'm increasing by 1. That was what goes in front of the x. Y equal 1x. And now I observe the 0 value. This is actually going to be called the y-intercept later, but it's 0, negative 5. When I plug in 0 for x, I have to get y equals negative 5. And there's my equation. Now I don't have to have the 1 in front of the x. 1x and x are the same thing. I can just write y equals x minus 5. And if I plug in another value, like this one, 3, negative 2, y equals 3 minus 5. When I plug in 3 for x, notice that I get negative 2. This was the x, and this was the y. A little review here, and then we'll get to questions from the assignment. This one technically is on the assignment, but I think it's important that we review. Remember quadrants. Quadrant 1 is where we spend all our time. In Roman numerals, that's quadrant 1. This is quadrant 2. We go counterclockwise. This is quadrant 3, and this is quadrant 4. Now, we're going to match 14, 0. Where is 14, 0? I go out 14 on x, that's that direction, and 0 up and down means I'm going to be on the x-axis. That's the horizontal axis. This is C. 0, negative 13. 0, for x, I don't go left or right at all, down 13. So I'm going to be going down there. I'll be on the y-axis at negative 13. That's on the vertical axis. That's D. 7, negative 1. 7, negative 1 is out 7 for x and negative 1 for y, right in quadrant 4. That's quadrant 4, which is G. Negative 11, negative 2. Negative 11 is this way. Negative 2 is going to be down. I'll be in quadrant 3. Quadrant 3 is A. 5, 10. That's 5 in the x direction. So I'm going this direction. And 10, I'll be going up, which means I'll be in quadrant 1. That's F. 0, 0 is at the origin. 0 for x and 0 for y. That's B. And negative 8, 4. Negative 8 is in the x direction, negative 8. Positive 4 means I'll be going up 4. So this will be in quadrant 2. Quadrant 2 is E. You have a couple ways you could check this one. One, you could take values from the table and plug them in and see if they worked or not. Careful. A great example is if I take y equal x plus 3 and I plug in 1 for x, I do get out 4 for y, which is what this is. However, notice if I take y equal x plus 3 and plug in 2 for x, I get 5 for y, which is not what that point is, telling you that it is not this equation. So I'm down to the next one. Does this one work? Well, we can use some of what we learned earlier to answer the question here. The table's horizontal, but notice how y is increasing by 3. That tells you the number in front of, as long as x is increasing by 1, that is the number in front of the x has to be a 3 because you're increasing by 3 in your y values. This one's out. So I'm down to 2 of them. Now I don't have the 0 value, but I could create the 0 value. Notice that if let's pick a different color. If I go this direction, 0 would have been down 3. It would have been at 1, which means this has to be the answer right here. And if I pick any value from the table, like 413, I can take y equal 3x plus 1 and plug in 4, and notice that 3 times 4 plus 1 is in fact 13. I can see that it's correct. We had this equation on our last assignment, and I did some examples in the teaching part of this video. Take a look at this table and notice that we have x. X is 0. Our equation is y equals negative 3x minus 3. I can plug in 0, negative 3 times 0 minus 3, which is negative 3. In the next one, they give us y. They tell us that y is negative 12. So we'll take our equation, y equal negative 3x minus 3, and we'll put in negative 12 for y, and we'll solve. So we add 3 to both sides. We're getting x by itself. That's negative 9 equals negative 3x. Divide by negative 3, and I see that x is 3. For the next value, we have x. X is 6. So we'll take our equation, and we'll plug in an x of 6. Y equal negative 3 times 6 minus 3. That's negative 18 minus 3, which is negative 21. For the last one, they give us y, and we know that y is negative 30. So we'll take the equation, and we'll plug in a y of negative 30. Negative 30 equals negative 3x minus 3. We'll add 3 to both sides. That's negative 27 equals negative 3x, and divide by negative 3, and we see that x is 9. In this question, we're going to graph, but we first of all have to create the table. Take your equation, y equals negative 3x minus 2, right here, and take these x values and plug them in. Y equals negative 3 times negative 2 minus 2. That's positive 6 minus 2, which is 4. Y equals negative 3 times negative 1 minus 2, which gives us 3 minus 2, which is 1. Y equals negative 3, and you plug in 0 minus 2. So y is negative 2. And the next value is 1. Negative 3 times 1 minus 2. That's negative 3 minus 2, which is negative 5. And we'll take and plug in 2. Y equals negative 3 times 2 minus 2, which is negative 6 minus 2, or negative 8. Be observant and look for patterns in your table. A linear equation will always create a linear pattern of increasing by a constant, the same value every time. X increases by 1, and y decreases by 3. We're going down 3. 4 to 1, 1 to negative 2, negative 2 to negative 5. Look for that pattern because that tells you you're on the right track, that you've probably done it correctly. Plot your values. Negative 2, 4, negative 1, 1, 0, negative 2, 1, negative 5, and 2, negative 8. Notice the line is straight, just like it's supposed to be. Draw your line and you're done. For this question, you're trying to find which of these ordered pairs is a solution. You can eliminate some of the ordered pairs very quickly. 0, 0. Notice if I plug in 0, 0, I get 0 equals 4. That doesn't work. If I plug in 0, 2, 3 times 0 is 0 plus 2. That's certainly not 4. Those were quick to eliminate. This one is probably a good one to try. If I do 3 times x is 0 plus y is 4 equals 4, hey, that's a true statement. There's our answer. You just need to plug in the ordered pairs and eliminate them one at a time. Question 20 here is really quick. We're increasing by 1 like we like to see. Look for a pattern on this side. Negative 1 to 4. That's increasing by 5 on the number line. So this next value would be 9, increased by 5. Then by 5 would be 14. And by 5 would be 19. A linear equation always follows the pattern of increasing by a constant. If that wasn't easy for you to see, notice if you take 4 minus negative 1 and you subtract them, you get 5. That 5 is what you're increasing by. Just subtract the 2. Here's another table to make and an equation to write. X is increasing by 1, like we need. We're looking for a pattern. Negative 5 to negative 4 is increasing by 1. So negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1. Adding 1 every time. This is the number that goes in front of the x. So it's y equal 1x. And we're looking at the 0 value. When I plug in 0, I have to get a y of negative 4. That means it's a minus 4. So y equals x minus 4 is our answer. Another one, x is increasing by 1. We need that. Check out two of the values next to each other. Negative 2 to 0 is an increase of 2. We're going 2 as we go forward, going up 2. -6, -4, -2, 0, 2, 4, and 6. This number goes in front of the x, y equal 2x. We look at the 0 value. When I plug in 0 for x, I have to get 0 for y, which means I don't need to add or subtract anything. And I don't need to put plus 0 either. It's just y equal 2x. Last couple of examples. Look at this table. The question is it linear? You don't have to be going up by 1 for it to be linear. You have to be going up by a constant. That's the important thing. When we look at the x side, we are increasing by 2 every time, and that's okay. That means that number in front of the x would be a fraction. However, look at the y. -4 to -2, that's increasing by 2. -2 to -1 is increasing by 1. -1 to -5 is going down 4. This is all out of whack. This is definitely not linear, it's nonlinear. You have to be increasing or decreasing by a constant on both the x and the y for it to be linear. Now let's look at these other tables. Select all the following tables which could be linear functions. We're looking for both x and y to be changing by a constant. On the x side, we're increasing by 5. That's good. On the y side, this is y. Remember, k of x, h of x, f of x, that's just another name for y. We're increasing by 20. And then 20 again, and 20 again. So this one is linear. The second equation, x is increasing as we go forward by 5. 6 to 31 is an increase of 25. 31 to 106 is not 25. If this increases by 25, then this one would have to also. So this one is not linear. For the third table, 0, 5, 10, 15, you're increasing by 5. -5 to 5 is an increase of 10, positive 10. 5 to 15 is an increase of 10, and 15 to 25 is an increase of 10. So this one is linear. For the last table, x is increasing by 5 again. 6 to -19 is a decrease of 25. -19 to -44 is another decrease of 25, as is the last one. So this is also linear. Both x and y have to change by a constant.